everybody, and thanks for joining my talk. Today I would like to introduce some of the tooling that we have added in the Buildroot project recently around supporting security vulnerability tracking. So I'll start by introducing myself. I am Thomas Petazzoni. I am the co-owner and the CEO of Buildroot, which is a company I joined in 2008 as the first employee. I am also a member of the engineering team and training team at Buildroot, and I happen to be contributing to a number of open source projects amongst Buildroot. I've been contributing to Buildroot also since 2008 and contributed several thousand of patches to that project, which made me become one of the co-maintainers. I happen to be based in Toulouse in the southwest of France. So in this talk, I would like to briefly introduce what is Buildroot, but I will kind of assume that most of you know what Buildroot is and what the purpose of Buildroot is. Then we will talk about build system and security vulnerabilities and what relationship there is between those two topics. We'll introduce some of the acronym soup, such as NVD, CVE, CPE, and what they all mean. And then we'll look at what security vulnerability tooling we have introduced in Buildroot and identify some limitations and possible future work, and then it will be open for Q&A. So what is Buildroot? Buildroot is an embedded Linux build system. This is a tool that allows to automate the process of cross-compiling a complete customized Linux system for any embedded platform. So it allows to produce a root file system with many applications and libraries, a cross-compilation toolchain, one or several bootloader images, and as well as a Linux kernel image. So it plays kind of the same role as OpenEmbedded and Yocto or OpenWRT or pkgstat or that kind of tooling. It has over 2,800 packages, which support the most popular open source libraries and applications, ranging from Python to Node.js, from Qt5 to Wayland and JStreamer, and more. One of the characteristics of Buildroot is that it is simple to use and understand. It's written in well-known technologies, GNU Make and kconfig for the configuration system. And it's a very active project which releases 4 stable releases every year, with one chosen every year, the February release, to be maintained during 1 year with security updates, something that will be really relevant for our discussion today. Again, as I mentioned, it's maintained by a very active community and it has a large user base in the industry with well-known companies such as SpaceX and Tesla using Buildroot. So to get started with Buildroot, it's pretty easy. You clone the Git repository, you cd into Buildroot. Probably you want to check out a stable tag such as 2021-02.2, which is at the time of this talk the latest stable release that we have. And then you can start by using one of the predefined configuration that we ship. Here I'm going to start by building a ARM64 system for the QEMU emulator. So this is just loading a predefined configuration. Then you can run miniconfig, very much like you would run miniconfig to customize your Linux kernel configuration. You can customize in the same way your Buildroot configuration and customize your selection of user space packages and many other aspects of your system. Finally, you run make, and it does the entire build in an automated fashion. And you can profit by using the ready-to-use images in the output images folder. Of course, there are many more things that you can do with Buildroot, but as a quick start, this is good enough. So the build systems such as Buildroot or OpenEmbedded, Yocto, and others are responsible for automatically downloading, building, and integrating all the system components. And typically, a large number of open source libraries and applications, as well as in-house proprietary applications, will be packaged into such automated embedded Linux build systems. And the number of components, open source or in-house, that gets integrated into a typical embedded system typically goes larger and larger as the complexity of system increases. So it has become really difficult, if not impossible, to manually track all the security vulnerabilities that can affect the software components that you integrate in your embedded Linux systems. So just like build systems typically offer license compliance tooling that allows you to ensure that you comply with the open source licenses of all the software packages that you include, it definitely makes a lot of sense to also have tooling to help tracking the security vulnerabilities that might affect some of the software packages that you're using. And that's precisely what we're going to be discussing today. So to start this tooling, we had to use existing databases. And in fact, there is a NVD database, which stands for National Vulnerability Database, which is maintained by a US organization called NIST, National Institute of Standards and Technology. And they provide a very well formatted database of all the security vulnerabilities that have been publicly reported. So this is the base of the tooling that we have added in Buildroot. The first thing that they provide is a database of CVEs. This is usually a fairly well-known term in the industry. It stands for Common Vulnerabilities and Exposures, and it's a reference for publicly known security vulnerabilities. Some well-known CVEs like 2014-0160 is Earthbleed, 2017-5754 is Meltdown, or 2020-24588 is one of the recent wireless frag attacks that has been disclosed. And of course, there are many more CVEs that are being registered and reported every year. And this CVE database is recognized in the industry as the reference identifier, and CVEs in general are the reference identifiers for known security issues. And NVD provides a per year JSON dump of the CVEs, publicly available, that you can download as visible on the slide. So this is a very convenient database to get access to CVEs. So it looks a little bit like this. This is just a snippet for one particular CVE, in this case CVE 2020-29074, which was reported against the X11 VNC project in version 0916. So this is the version that is affected by this CVE. There's just one single version. Here is another example of CVE, CVE 2018-733, which was reported in 2018, which affects OpenSSL. A number of security issues affect OpenSSLs, as you probably know. And in fact, this CVE here affects a range of OpenSSL versions. So the JSON description is a little bit different, and we can see those versions start including, version end including, that describe an entire range of versions from 110 to 110G, which are affected. The NVD website allows to nicely browse the database of CVEs and allows to see which configurations, so which versions of the software package are affected. So if we look at this specific 2018-0733 CVE that we were talking about, we can easily see the complete list of versions that are affected by that CVE. So if you happen to be running one of these OpenSSL versions, you probably want to look at whether this CVE is important to you and possibly update your OpenSSL version accordingly. The next topic is CPE, because if we scroll back a little bit, we can see that the references to the software package is made using something called the CPE23 URI. So this concept of CPE is also introduced in this NVD database. CPE stands for Common Platform Enumeration, and Wikipedia tells us it's a structure naming scheme for information technology systems, software, and packages. So if you put that in more regular speech, it says it's basically a unique identifier for software releases. Every software package that produces a releases will be identified by a unique CPE identifier. So a CPE identifier goes like this. It starts with CPE, then the version of the CPE spec, currently 2.3. Then there is a part, which typically is A for most of the software packages, which stands for application software. Rarely it can be O for an operating system like the Linux kernel. Then there is a vendor part, which is the name of the project or the organization that issues the project. Then there is the product, which is the name of the software itself. Then the version, the update is like a minor version. And then there's a whole bunch of extra information that can be added, but that are rarely used. So here are two examples of CPE identifiers for NTP, so the Network Time Protocol implementation in version 4.2.8 P3. So P3 is in another field because that's the minor release. Or the X11 project, which is published by an organization that is identified as X11 project, and the product is X11 in version 0916. And this CPE dictionary is provided by NVD. It lists all the known software releases as a huge XML blurb, which gets regularly updated by NVD as new software is being released by open source projects or even non-open source projects as well. And these CPEs are the identifiers that are used in the CVE database. So it's important to understand CVEs on one side and CPEs on the other side. So in Buildroot, we add an existing tool called pkgstat, whose goal was to collect statistics about all the packages in Buildroot. So it was really maintainer-oriented, Buildroot maintainer-oriented, in the sense that it was collecting data on the entire set of packages in Buildroot, not specifically for one given Buildroot configuration, but really the entire package set. It was providing information such as, does the package has a license file information, does it has a proper hash file, whether the currently packaged version is up to date versus the latest upstream version available from the original project, and a few other information. And what we did in the past year is that we extended that tool in two directions. First, we extended it to cover only the set of packages for a given Buildroot configuration, because this is really what matters for a particular Buildroot user. You have built a system with Buildroot, you want to know which packages you have in your system and potentially which CVEs affect those packages. You're not really interested in the other 2,000 packages that Buildroot may offer. You're probably using only a small subset of those packages which are relevant to you. So that's one of the first things we did. And then the other thing we did is that we extended that tool by making it use of the NVD databases, the CVE database and the CPE database. So we are able now to detect if one package that you have in your system is affected by one or several known CVEs. And to use this tool, it's pretty simple. You simply run make pkgstat, and it will collect the list of packages you're using, the versions you're using. It will download the NVD databases and match your packages against the database and produce some results. Those results are available as JSON output for nice and easy parsing by your own custom tooling, or also as a nice HTML page. This tooling is available since Buildroot 2021-02, so it's been relatively freshly introduced, and we hope to extend it further in the future. So the actual output looks a little bit like this. Of course, the exact output might be slightly different depending on your configuration. And it has been a bit stripped down on the slide to fit, but basically for every package in your configuration, it tells you what version of the package you're using. If this information is known, if there is a newer release available upstream, the fact that you're not up to date may be normal, right? If you're using a relatively old Buildroot release, it's quite likely that upstream projects will have made new releases. And then it tells you a few other information that are not really relevant to our discussion. And then we have this CV column, which lists CVEs that can potentially affect you. And you can see there's a number of CVEs listed there. And then there is a CPE ID column that indicates whether the CPE identifiers for that package are known and are correct or not. And we'll get into the details of that. So the CPE identifiers need to be known by Buildroot, because these are the key to match with CVEs in the CVE database. So by default, for every package, Buildroot automatically thinks that the CPE identifier is like this: CPE 2.3a, name of the package _ project, name of the package and version of the package. So if we have no other information, we will assume this is a possible CPE identifier for your package. Sometimes, however, that doesn't match with how the software component is referenced in the CPE dictionary. So you need to add extra information in your Buildroot package. And this is done by providing explicit CPE identification information in your package using the CPE ID variable. CPE ID prefix, CPE ID vendor, CPE ID product, CPE ID version, CPE ID update. And you can use any combination of these to describe accurately what is the correct CPE identifier for a given Buildroot package. And the pkgstat output indicates if the generated CPE identifier for every package has been found in the CPE dictionary. If it has not been found, then it either means that the CPE information in Buildroot is incorrect, like maybe the project name or the product name is not how it is referenced in the NVD database, but it can also mean that the NVD database is incomplete. Indeed, even though the maintainers of the NVD database are doing a great job at keeping it up to date with software releases from all those open source projects, it is really hard to keep track of them all, so they are not necessarily having the latest versions of all the software releases. So it may also be that the NVD database is incomplete. Over the past months, we have been doing a lot of effort in introducing the CPE identification information to Buildroot packages to make sure that it is as accurate as possible, but there is a lot more work remains to be done in that area by introducing more CPE metadata to Buildroot packages. So if we look more precisely at 4 examples from the previous pkgstats output, for the ATTR package, ACL package, ATOP package, and BuzzyBox package, it will give the following details. So for ATTR, we can see that for this package, we have some CPE ID variables defined, which means that someone in the Buildroot project has verified that the CPE identifier information in that package are correct. And indeed, this cell is green with CPE 23A, ATTR project, etc., which means that not only the CPE information is verified, but also that a match has been found in the CPE dictionary. Also, we can see that the previous column is N/A, which means there are no known CVEs affecting that particular version of that particular package. Moving on to ACL. For ACL, we have no CPE ID variable defined in that package. So Buildroot derives a default CPE, but we don't really know if this is a correct CPE or not. So we are warning you that there is no verified CPE identifier. Based on that default CPE identifier that we generate, we have found no CVEs in the CVE database affecting the version of ACL that you're using. Moving on to the next package, ATOP. For this one, we have a CPE information available in the package. So it has been verified by a Buildroot developer, but it turns out that the NVD database doesn't know about that specific version of the ATOP project. So probably there is a contribution to be made here to the NVD database. In addition to that, based on that CPE identifier, we were able to find that one CVE is affecting that version. So you might find that odd that the CPE identifier is unknown in the database, but still we found a CVE. And the reason is because that particular CVE is registered in the CVE database as affecting all ATOP versions. So this is probably incorrect in the CVE database and should be refined in some way. But as it is, if you take the CVE database, this CVE affects all ATOP versions. Finally, the last example is with BuzzyBox. On the CPE identifier information, it is in the same state as ATOP. We have verified the information in the package, so there is at least one CPE ID variable defined, which indicates that one Buildroot developer has verified the CPE variables. But this particular version of BuzzyBox is not known by the NVD database. So here as well, we probably need to contribute to that database to register this new BuzzyBox release. But based on that information, there was no known CVE that was found. Sometimes a CVE is reported as applicable to a particular version, like it is the case for ATOP, but for some reason it should be ignored by Buildroot. The typical reasons are either that Buildroot has already backported a security fix as a patch in Buildroot directly. So we typically do that quite often when there is a security issue in a software package and there is no new release available for the moment. We simply take the security fix and backport it and integrate that directly into Buildroot to make sure that all our users benefit from that security fix. But in that case, the version of the package remains the version that is vulnerable to the security issue, but we want to ignore the CVE because we know that we have the appropriate fix for it. The other reason that exists is that the security issue may not necessarily apply to the Buildroot configuration or usage of the package. Maybe it's only there because of the Debian specific packaging. Maybe it's only there because of some specific config option that we never enable in Buildroot or something like that. So in these cases, we have a per package variable called ignore CVEs, which packages can use to say, okay, this CVE will be reported as affecting me, but you should ignore it because some reason. And in the slide, you have two examples where the bind package says to ignore CVE 2017-3139 because it only applies to a certain distro and a certain aspects of that distribution which do not matter for Buildroot. And you have another example with hostapd where we say that we should ignore CVE 2021-30004 because we have a patch and the name of the patch is given, which was already backported in Buildroot to address that security issue. Nevertheless, that tooling is great, but it does has a few limitations. First, the packages where custom versions can be specified will not be handled really well. There are only a few packages of that nature in Buildroot, and those are mostly hardware-related packages like Linux, U-boot, Barebox, ARM-trusted firmware, for example. Because for those packages that are typically tightly coupled with the hardware, it is very common for users to use non-official versions because you have a fork of the kernel for your specific board or SoC or another reason. And in those cases, you will typically use some kind of git hash or a custom git tag to refer to the version of your Linux kernel or U-boot. And there is no easy way for Buildroot to map that to what specific upstream kernel release it corresponds to and whether a certain set of CVEs might be affecting you or not. So this is not something that we are handling at the moment. Another limitation is that the CPE dictionary may not be complete. We already saw such examples in the previous slides where the latest version of BuzzyBox 1330 wasn't known in the CPE dictionary. Or there may be inaccuracies in CVE reports. For example, the ATOP package was affected by a CVE that affects all versions. This seems a little bit suspicious and probably is worth investigating. But the NVD maintainers are open to contributions, and the Buildroot project, several developers and contributors have already submitted changes to the CPE dictionary or to the CVE database, and they were accepted by the NVD maintainers. Also, another very important aspect is that this whole tooling is only based on publicly reported CVEs. So it only matters if you trust CVEs as being the one true reference for security issues, but it is fairly well known that there are a number of security issues that are not reported as CVEs. For example, the kernel community quite prominently states that not all security issues are reported as CVEs because it is sometimes difficult to assess whether a particular fix is fixing a bug that is exploitable from a security point of view. Another aspect that is important is that in a lot of embedded products, you have a combination of open source components and proprietary in-house components. And the CVEs are only reported for open source components typically. But in many cases, we see that the code that is written in-house is poorer than open source code from a security point of view. It's of course not always the case, but it's usually less reviewed, less tested, less exercised than open source code. So there may be security issues in your own code which the CVE database will never tell you a thing about. So the whole point I'm trying to convey here is that it's not because you have a completely clean output of CVEs for your Buildroot generated system that your system is secure. So to conclude, the security vulnerability tracking has become really important to keep devices updated, especially when they are network connected or generally accessible to users. NVD provides some really useful databases in nicely machine parsable formats. And the pkgstat tool and make target in Buildroot is the entry point to use such databases in a Buildroot context. So we probably recommend you to run that make pkgstats in a cron job, monitor the results. And if you discover that a package is affected by a CVE, you can see if a version upgrade is necessary, or maybe you'll need to backport the security fix and update the ignore CVEs variable. And obviously, we would like you to help us by contributing the result to upstream Buildroot. I hope you will have found this talk interesting, and I'm now available on the chat for Q&A. Thank you very much for watching.